All right, so we're gonna start with 5. I think the number 8 that you guys wanted was the second number 8. I think.
Yeah.
Yeah.
Sure.
Yeah. I don't think it's both number 8s because the first one isn't bad. But then this is about Chicago. Okay, so all right, so let's start with 5, A, B, and C. So it gives us this big equation, and then it says state P of 4 and tell whether it's true. So P of 4 is putting 4 into this equation. Oops, yeah. And this is a formula that exists. I believe that's it. So if I put P of 4 in there, I'm going to put 4 everywhere the P, or everywhere the X shows up. So 4 to the third minus 1, 4 minus 1, and then 4 squared plus 4 plus 1. So everywhere there was an X, I put a 4. So 4 to the third is 64 minus 1 is 63, I believe. This is 3. So 16 plus 4 plus 1. So that'll be 21 times 3, which is 63. So 63 equals 63. So P of 4 works. Then they say write this P of the square root of A. So I was talking to some people before we left, and we kind of thought that maybe they wanted you to take the square root of 4, and that would be 2. So you could do P of 2. You would find out that works as well. Now, I looked in the book, and that's not what they wanted us to do. What they wanted us to do, but it's good to check it anyway. So this is 1. This is 8 minus 1, which is 7. This is 4 plus 2 plus 1, so 7. So 7 equals 7. So P of 2 also works. So if you did it that way, that's fine. What they wanted you truly to do is put the square root of A in. I don't know how that would be helpful in terms of checking to see if this works, because if you see it written that way, it's kind of a little bit of a mess. So this is fine. If you put the square root of A in, it just looks kind of like a messy equation. Now it says, does this work for all values? And so Paige said you found 0 did not work. So let's check. I'm wondering if you just, because it said for all real, right? Yeah, so let's check and see if 0 does work. So she thought maybe it didn't, but I don't know. I'm assuming it does work because this is actually kind of a formula, so I don't know if just, oops. So 0 to the third is 0, negative 1, this is negative 1, oh, this is positive 1, so negative 1 times positive. So you must have done something goofy.
I thought 0 to the third was 1.
Yeah, no, that something to the 0 power is 1. So I'm sure that's what you're thinking. I don't know. So, so then let's go to number 10. Now number 10, they wanted you to substitute values in to see if basically if that works. So, yeah, so let me, so in number 10, we're using this formula. And they give you some values to try. They say, tell me that, or they say, give you that A is the square root of 75, B is the square root of 12. And so they're saying, does that equal 147? So we're going to put that all into this formula. So they're basically telling you to substitute those values in. lot of it without a calculator. The square root of 75 squared is 75. Square root of 12 squared is just 12. The square root of the squared cancel out. But then, adding those square roots and then squaring them, initially it looks kind of bad, but so the square root of 75 plus the square root of 12 is kind of an awful number, but when I square it, it ends up being 147. So I put that into my calculator. That's not something you probably do off the top of your head. So this is 147. And then over here, I did 2 times the square root of 75 times the square root of 12. And this is 60 here. And then when I add those 3 together, I get 147. So it was basically they were giving you values for A and B and asking you to substitute them in. So number 14 is not from this one. So the next page we'll go to, the page 15 and 16. Let's start with number 6, it looks like. I'm guessing this one just scared you because of the sine and cosine, because we haven't really done like trig identities or anything like that. There's a few times in this book they kind of assume you've done more than you have maybe coming into it. So that just kind of happens sometimes with upper level books, and so I try to avoid those, but hopefully this one wasn't too bad. Okay, so there exists a real number x where sine equals cosine. Now, this is not one you're probably super comfortable with because knowing that sine equals cosine, the function, it's not something we've really talked about yet. Algebra 2 doesn't really get into that. We will talk about this eventually. So this is probably more one that I probably could have skipped, but remember, when they have there exists, we switch that for all. So we switch it to the for all. So for all real numbers, we basically just want to flip this. So not equals. So don't let this freak you out too much. I'll avoid stuff that you're not super comfortable with, like on a test, but like something like this that you can flip it. Yeah?
Why isn't X not in the second one?
Oh, you can. I'm trying to be brief. I sometimes probably leave out too much, but yeah, so all real numbers X. Yeah, you can put that.
Okay.
I'm not going to be super, like I get shorter and shorter as the problems go on, just to save time maybe. All right. So they want us to negate, in number 8, some quadratic equations have 3 solutions. So some quadratic, so that's this one. So have 3 solutions. And they want us to do the opposite of that. So when it's sum, we're saying for all real, so all. And then we want to switch it to basically have 3 solutions to don't have 3 solutions. So all quadratics do not have 3. And that's kind of confusing. So what they switched it, why would they switch it to all quadratics do not have 3? They don't have one exactly like that, so we have to find the one that's most similar, because none of their choices fit this. All quadratics don't have 3. So another way to say that, rather than saying all quadratics don't have 3, it's saying no quadratics have 3. So just trying to be comfortable with rewriting that if that's not an option. So kind of seeing that those are really equivalent statements. And then number 14, kind of a similar one. It says no one under 21 can legally buy alcohol in Illinois. So no one, so that's an all statement. So all people under 21, oh, no one. So for all, there is no one who can buy alcohol under 21. It's not that kind of buy. a true statement. There is no one who can legally buy alcohol under 21 in Illinois. So now we need to kind of switch that up. For some, but remember this one now needs to be false because that one was true. So there exists someone. So there was no one and now they can. So there exists someone who can legally buy alcohol under 21. So, oops. So this one was no one. So this would be some exist. So just kind of flip that. So again, watching out for that true false piece of this and kind of being able to switch that back and forth. So they use the word for all and then the word all or everybody, and then for there exists somebody, like just someone, just like a single statement. All right, I know this is tough, but hopefully it'll get better. We're not going to have a huge test on this, just trying to get comfortable with some of this phrasing more than anything. Truth tables are something that we're going to work on a little bit more today. We'll see those a little bit. We're going to go to notes. I'll get you guys those. Just a reminder that tomorrow I need you guys to have headphones because you guys will be watching your video online, and that will be uploaded by the time your class starts. So just that you guys, I won't open it until your class, otherwise you have nothing to do during class. Now, tonight's homework, I won't check until Tuesday. Miss Miller will be in here with you guys, but I'm not going to make her check homework, so we'll go over homework together on Tuesday. So basically on Tuesday, you'll have 2 homework assignments you have to turn in. If that makes sense. It's just easier than having her having to worry about checking homework and answering questions, especially when she's not in here. So let me get you guys the notes for today. And you guys will still get like a note packet to fill out for tomorrow. Now, the copying machine was being really naughty, so it was doing all sorts of crazy things. So if you get if you get one that you can't read, let me know. It was like folding paper and stuff, like it was doing things it wasn't supposed to. So if you get something weird, let me know. There was a few that were all crinkled, but I think I grabbed those last year. And then probably a little bit later today, I'll probably write down where you guys are sitting, just so there's a seating chart for Miss Miller. I think she knows most of you guys, but it's good to still have a seating chart. Alright, so just to remind you guys, we're going to talk a little bit about inequalities today, but also and or statements, and where those come up most frequently that you guys have seen it before is compound inequalities. So this was considered a compound and inequality. So this might take you back to algebra or algebra 1, trying to solve for the x. So if you want to take a minute to do that, I'm going to take attendance quick and then we'll talk about it together. Where did Dylan sit yesterday? Alright, we're moving on. Yes. Alright, how'd we do? Do you guys remember how to do this?
No.
Alright, someone who's confident, what do you want to do? What do you think, Maria?
Subtract 5 from the -2 and the 1.
Yeah, so the x needs to get alone in the center. So whenever we do the middle, we have to do to each side. So if we're subtracting 5 from the middle, we have to take it away from either side as well. So it's basically like it gets subtracted like 3 times. And you might not notice the one in the center. So all the places need to get the -5. But this is something you do like once or twice in algebra or algebra 2, and then you don't touch it again for a while. So that's our new inequality. And if you guys recall, what this is basically saying, this is an and compound inequality. It's saying x is in between -7 and 4. So it's in that range of values in between -7 and 4. If you guys remember when we graphed this, we like put it on a number line and we said from -7 to 4. We filled that in, we left that one open. So that's like
Is
some.
that what we're doing?
No, we're not. But I just want you to think about it. It's in that range of values. It's got to be greater than -7 and less than 4. Kind of like when you guys, like there's age ranges of students that can be in high school. You can't go to high school for the rest of your life. Like, I mean, there's a limit to how old you can be in high school. I know you all want to, but so just understanding that there's a cutoff for that. So the age range is important, and this is an example of that. So an and compound inequality, or an and statement in general, is both have to happen. So and is saying both A and B have to work, or whatever it is. So both must, so if we're talking about P and Q, both must be true. Oops, I can spell. So this is not playing the mom or dad game. This is It's like both of your parents have to agree to let you go wherever it is. It's not like I'm going to ask mom, I'm going to ask dad, and whoever I get a yes from, I'm going to go. It's got to, both have to agree. So both must be a yes. The or is one or the other. Sometimes you hear both could work. It depends on the situation. So basically, P or Q. Let me change that up. So one or the other could say yes, or both could say yes, but both can't say no. Does that make, so like one or the other must be true. I don't know what I was going to write down for not. I should probably look at that. So for not, basically what they're talking about here is using the symbols for like not equals, not greater than, not less than. So so you can have not greater than, not less than. So you might see those symbols. So, which one is, so they want us to write out, is it and, or not? And when we write them out, we want to write out, like, the parts of it that are true. So, like, so hopefully you guys realize this is considered an and inequality. But how would you tell someone that who's not comfortable with this? So -1 is less than y is less than 10. How would you read that to someone who doesn't understand what we're talking about? Y is in between -1 and 10. Can we use inequalities to explain it a little bit? You can probably like that's not any more helpful. So what's y compared to -1? Greater than. So y is greater than -1 and what is y? Less than 10. So it's kind of breaking it down into the two parts. All right, what is this one saying? M is what? Or equal to, greater than or equal to 6. So write this out in a way that someone would understand. So this is an or. M is greater than 6, or M is equal to 6. So kind of just writing that out as obviously as we can. The last one here is saying x is not greater than -8. So what could x be then? So this one's kind of a little bit different there. What values of x would make sense then?
Less than or equal to.
Could be less than or equal to. So just that you're understanding that you can write it both ways. Kind of just breaking that down a little bit. Okay. So we're going to do some truth tables, and these are just trying to help you to see, kind of maybe understand things a little bit better, or like if you're trying to figure out, does my statement still make sense? We want to make sure that it does. So I will show you guys the way that looks. So you're going to want basically 4 lines and 3 columns. Actually, we might want one more, sorry. Can you set another one in there? So this is P, Q, P, and Q. So if P and Q are both true, so think about it as a yes, like mom and dad both say yes. If it's an and statement, is that true or false? True. So mom and dad both say yes, it's a yes. It's not like it automatically flipped to false. But if it's one of them say false, or one of them say no, what's our outcome going to be for an and? False. So if mom and dad don't both say yes, then the answer is no. Get on the same page, mom and dad. So, how about they both say no?
No.
2 wrongs make a right. So then you can go. That's a no.
So we should disobey our parents.
Right, yeah, don't listen to your parents.
Let's go.
Moral of the story. Did Brad really get in trouble yesterday?
No.
Oh.
That would have been so fun.
My mom used to be saying that when I got sent to the office for talking back to the teacher.
And
then
we for sure thought it was
we
hilarious.
thought it was boulders.
Like, that's actually really believed.
Who was it? There was no one, she was pranking me. Oh.
But you said you got in trouble first.
Yeah,
You
I
started
never got
it.
to the final, I got expelled. Which I did. Okay. Whatever you say, Maddie. I'll go. Yeah, let's go. Just kidding.
So this is one of those households where you keep going to the other parent to see who's going to say yes. You know, we all have those, you know, families that happens. Well, mom said yes, I don't care that dad said no, or whatever it happens to be. Now, if they both say yes, even though it's an or, it still is true if they both say yes. So if the first 2 are both true, so is the last one. But then one or the other can say yes. So this now is true. Oops, sorry, that F is struggling. And then flipped of that is also true. The only one that's false is if they both say no. You get a no from one, you go to the next one, they also say no, yikes, you're out of luck. Now, obviously these questions aren't going to have to do with asking your parents for things. It's going to have to do with, is the first half of this statement true mathematically, or is it, you know, in a real situation, is that true? And is the second half true? Is one or the other going to work? This is what I was talking about. There's either an exclusive or an inclusive or, depending on, just in our normal language we use this. So exclusive or is one or the other, not both. So this is if I'm saying you can either take a break outside or take a break and go to the drinking fountain. You can't do both things, one or the other. That's in everyday language, we use this a lot. This is not the kind we're using here, because one or the other is still true. What we're using inclusive language, where it is okay to say both. So inclusive. So this is kind of asking the question, do you want cream or sugar in your coffee? And you might say both. I mean, you don't have to choose one or the other. That's perfectly fine. So we're going to be using this one. So in math, we're going to use this one. In everyday language, it's okay to use that exclusive one. Don't tell your teacher, well, no, now Mrs. Donahue said I could choose both. Like, you know, like, no, we learned in logic that that's not the case, so no. Don't get me in trouble. All right, we'll do a little bit more notes and then we'll take a break. Let's get through like the top half of this. So a logical expression what we're talking about is talking about using things like and or and then like P's and Q's. So it's kind of bizarre with this, but we just want to make sure we use parentheses if we're combining more than one thing. So if I say, so using I'm going to say etc. because we have an R in there, we have different letters, and we're going to use and or not, and then if-thens. You can also use parentheses to show which you want to combine. Let me show you guys what I mean. So if I say P and Q, whoops, or, let me move that. If I say P and Q or R, like what's going on like with all that. So one of the things you might want to do is throw parentheses in so that you know that first you figure out P or Q and then do the and. So kind of like an order of operations type thing, so make sure you use parentheses if needed, if there's more than two values that you're working with. And then this logically equivalent is understanding sometimes things aren't exactly going to have the same outcomes. So for instance, this kind of came up in your homework last night. So if I say not P, are we going to use this squiggle? What is that going to equal? P. So this was in your homework last night that they kind of cancel each other out. So understanding there's times that something is logically equivalent to something else, I could say that instead of like saying not. It doesn't make sense there. Okay, so we're going to do this truth table just to kind of work a little bit with like the parentheses and talk about that. So I'm going to do the top row with you and see if you can kind of fill in the rest. So we talked about this with true, P and Q, then would also be true. Now this is saying not P and Q, so you're doing the opposite of P and Q. So that's going to be false. Then it says not P, so the opposite of true. Not Q, the opposite of true. And now it wants me to combine these two together. So not P, not Q. So false or false is going to be false. So see if you guys can fill in the other lines. If you're really nervous and you don't have a pencil, you can wait, but see if you guys can fill those other three lines in. Yeah. Yeah. And we will take a break after this. My foot killed me yesterday, so and is the one, it has to be both. So T and F together was going to be what? T and F together, false. Okay. And I don't know if it helps to go down the line, because maybe that's easier because you're just more comfortable with, so then this would also be false, this would be false. So if it helps to go down the column instead, maybe that's easier just in terms of like changing your mindset every single row. Now this one's saying not this column. So the opposite of this column. So that's going to be all trues. The next one is saying not the P column. So we're looking at that first P column and we're just going to do the opposite. So that was true. This would be false. That was false. So this will be true. Then we have not Q. So looking at the Q column. So that was false there, so true. And now we're taking these two columns and doing or. So these two columns, remember it's one or the other. So one or the other said true, so that's okay. One or the other said true, so that's okay. One or the other said true, that's okay. What this chart is trying to get you to notice is that there's going to be times that two statements are logically equivalent. So if you look, this and this are identical. They're truth table outcomes. So these can be considered logically equivalent statements. I could say either of those and they both would mean the same thing. That's why when we were writing some of these sentences, it was kind of like, well, that kind of sounds the same. That's because things that, especially when we're using nots and ors and ands, like a lot of times you could really say something a little bit differently and it still means the same thing. So let's pause for a minute because we've been taking notes for quite a while. I'm going to pause our video here.